Okay, now that you went through the video with setting up Community Edition, here I have an example cluster I set up that's running on Proxmox. I won't get into the details on how to do that. If you do a search on the internet, you can actually set that up. Here is my Nutanix CE node here running on Proxmox. I log back in, and now what we're going to do is we're going to go and set up your networks. So go to the VM tab or go to Settings. Go to Network Configuration, and within here you're going to create your subnets, which is your tagged VLANs. Your default VLAN would be 0. Your tagged VLANs, and I know that's contradictory to what you normally view as a default VLAN. Typically default VLAN is 1, or whatever you mark as native, right, on the trunk. I'll just tell you that in our case we call it 0, so you can call it whatever, and your VLAN ID would be 0. If you decide to have other subnets, which in the cluster that's actually configured already, we'll show you in a few minutes, you would add it in here. So say you had a server subnet and the VLAN tag was, say, 63, right, as an example. You could tag that and you would allow 63 across those uplinks. Another thing you can do is enable IP address management, or IPAM, where you can actually present a network IP prefix. So let's just use 192.168.63 as an example to match the VLAN /0, and then we'll call it a /24. Let's just assume that the gateway on this is 168.63.1, and then you could set up your DHCP settings like your name servers, right? So in my case, mine is 192.168.50.11, 10 and 12. Domain search, I would put in here, mslab.local, which is my domain search. My domain name is mslab. You could do a TFTP server or boot file if you'd like, and then you can create a pool to actually dole out addresses. So if I want to create a pool, 192.168.63.100, 192.168.63.199, and that will be my DHC pool. And I could override the DHCP server. Basically what happens, if it's unspecified from an IP address, it'll use the highest unallocated unicast address in the subnet. So in this case it would be 192.168.63.254 would be the DHCP address. Now if you create this and you enable IPAM, what happens is Nutanix, upon the VM boot, will do what's called a VXLAN intercept, right, for the DHCP traffic, and Nutanix IPAM will dish out the IP address through the pool. Now there are a couple ways to do this. You can have an automatic, right, assigned through DHCP, or you can actually create statics within the pool as well. Or if you don't want IPAM at all, you just don't enable IPAM and you create your own statics or use your own external DHCP. It's common in large enterprise and production use cases that those folks have their own IPAM solution, whether it's info blocks or something else, managing their IP assignments. But in the home lab, this is very, very handy to have IP address management built within the platform. You don't have to worry about enabling that within, say, your domain controller or a separate server using that service. You can do that here. Once you have that set up, you're going to go back in, and on the home page, you're going to register or create new a Prism Central. So what is Prism Central? Think of Prism Central as the quote-unquote, for lack of a better term, a vCenter-like control plane. It's a little bit different, and I'll show you in a few minutes, but think of that as a control plane, right, for your cluster. Also think of it as your API gateway for your cluster, and not just cluster. If you have many clusters, think of it as a centralized management solution. And what you can do is you can click deploy and click this box. It'll download this version of Prism Central. You can upgrade this later through LCM, which is our lifecycle management. I'm not going to get into that. And you're going to give it an IP address, etc. I would say a single VM PC is fine. We usually deploy a scale-out PC, which is a distributed deployment of Prism Central in production, in enterprise accounts, etc. We'll hit next. What type of environment you have. More than likely in a home lab, it's going to be small, right? So you'll choose small. You'll select the subnet, In this case, what will happen is on the previous page where you added the VLAN tag for the server subnet, in my example, it would show up here and you'd be able to either automatically assign the addresses or statically assign it. If you automatically assign it, it'll assume an IP address out of the pool that you assign. The subnet, gateway, DNS, etc. will automatically deploy, fill these fields in, and you'll choose a container which is your data store. I'll choose the default container. I'll name my VM, and this IP will automatically be given if you choose an IPAM. If not, you have to statically assign it here. Okay, so you'll deploy that. When that's deployed, you'll go into Prism Central, and I'll show you what that looks like. So let's now log into a Prism Central console that I have already configured. I'm going to log in with my local account, even though I do have my identity sources domain. We'll just make this easy. So I'll log in as admin. I'll use my password. There is a default password. You can look it up online. I'm not going to say that right here to get you started. And it'll actually ask you to change the password upon your first login. But I've already done that. So let me just log in with the password I had changed to. And now we're going to log into Prism Central. Now, it does look a little different because it will automatically be in light theme. You can actually go in and change that, right, to dark mode, which I've done. But you'll also go in here and go to Prism Central settings, the first thing you'll do, and you'll configure your, under more settings, your DNS, right, your NTP, etc. before you attempt to, you can see here NTP, my NTP servers are here. Again, this is just a lab. Oh, here are the UI settings where you can change it to dark, and you can actually change the session idle timeout settings, etc., etc. But what we're doing here is we're getting Prism Central basically ready to be leveraged. So in my case, when I go back to the hamburger menu and hit infrastructure, you can already see that my cluster is already connected. In the case that I showed you on Prism Element, what you would do is after you've done the settings, right, you've logged in directly to Prism Central, you updated the DNS, maybe you wanted to use an identity source, right, such as your domain controller, you set that up, you add your groups or your users for access, your NTP, etc. You'll go into this and you'll hit register create again, and you'll hit connect. And here what you'll do is you'll point to that IP address, the port will be 9440, and you'll use the username and password that you logged into Prism Central with for this cluster to register to Prism Central. Okay, this is just an example cluster I use. It's not registered to any Prism Central instance. I already have a physical cluster that I've already set up, and I already have a Prism Central instance running there, which you can see here as I go back to Prism Central. Now, most of the time you'll be in the infrastructure side. One thing Prism Central also provides is our ability to integrate our Upstack products and services, right? Like Kubernetes, and we'll talk about that later as we get further down in the Kubernetes discussion around what's out there from a Kubernetes operations, automated operations and control, right? Solutions, right? So you have things like Rancher and you have OpenShift, and those are the things I talked about in my previous articles. But also Nutanix has its own native solution called Nutanix Kubernetes Engine, which is called NKE, which I'll show you a little bit later. Right now, we're just going to use the Nutanix infrastructure, right, from a storage perspective and a hypervisor perspective. I'm going to be using IPAM. I'm going to show you what that looks like. And we're actually going to set up a entry-level cluster with a single node control plane and a single worker node. Okay, and we'll add that node to the control plane for Kubernetes. Now, I've already set up, right? I've already set up my network. So in Prism Central, I can go into subnets, and you can see all these subnets here. And I'll be using the server IPAM VLAN, okay? But I won't be using DHCP, and when I walk through that, I'm going to tell you why in a little bit. So first and foremost, what we're going to want to do is we're going to download the Ubuntu image. I use the cloud images. In those cloud images, right, you can find on this site, the cloud-images.ubuntu.com, and you can see here all of the Ubuntu cloud images. What I like about these images is that they're official, right, images that have been customized to run canonical to run on public clouds. Now, you would say Nutanix is not a public cloud. It is a private cloud solution, and you can still leverage these. They're smaller images, very minimal, which I like, especially for Kubernetes. And as we get further into the discussion around security and operations, we're going to touch on some of the upcoming and popular distributions for operating systems, for node operating systems that we see out there, like Flatcar Linux and Talus, right? So those are starting to become more popular because they're very focused on just Kubernetes, and they're very focused on keeping the footprint small. What I like about these images is also a small footprint. I use Focal and I do use Jammy, but in our case we're going to use the Jammy Jellyfish Daily Build. So you click on Jammy and you'll click on Current, and I know you probably can't see this, so I'm going to make this bigger. And basically what you're going to look for is this current image, QCOW2 bootable disk image, which I've already downloaded. When you download that, you can come back into your Prism Central instance, and you can go back to Compute and Storage, and you'll see Images, and you'll click Add an Image File. You'll choose the Jammy. Here's an example, right? You can rename it, or excuse me, you can't rename it, but this is the, I take that back. You can rename it, this disk image, and you can give it a description and a checksum, right? And you can click Next, and you can push this directly to a cluster. And in your case, that's probably what you're going to want to do. But there's also placement policies that we have where we use a placement policy in a category. So I may have a category that says edge clusters, and what will happen is all my clusters will have that category of edge assigned to them, and I can just push it to all my edge or robo locations as an example. But in our case, we're going to place the image directly on the cluster since we have one, and we're going to hit save, and you're going to want that to upload. And it goes through a quick upload process, then it prepares the image. That takes a couple minutes. And don't go out of that page. Wait till that's done and completed. And what you'll see is, let me cancel this or get out of this. What you'll see is the image here, and you'll see the size and the type of image, right? So you can see here I have two images, the Focal image and Jammy, and I also have this Carbon. Don't pay attention to that. We'll talk about that later. It has to do with our Nutanix Kubernetes Engine Node OS image. But in our case, we're going to be installing Kubernetes manually, our first cluster, to walk you through the process to give you an understanding of what it takes to stand up a Kubernetes environment manually, right, for a learning process. So we're going to be using this Ubuntu Jammy image. So before we do that, there are specific things that have to happen, right? And I want you to go to kubernetes.io, go to installing Kubernetes with deployment tools, right? Or excuse me, production environment, go to container runtimes, and what's going to happen is, I take it back, go to production environment, because this is going to talk to you about what it takes to actually build a production control plane and a production worker node, or nodes as an example, or control plane, highly available control plane. We are not going to do highly available right now for worker or control plane. As a matter of fact, I could just do the control plane and untaint that control plane to allow pods to run, applications to run, so I have an all-in-one solution, but I'm not going to do that. Generally speaking, it's not good practice. If you are going for your certified Kubernetes administration exam, you may run into clusters or the lab environment as you go through that process, right, of learning, where you'll have a single node that's a control plane and is untainted, right, which basically allows it to run production pods, etc., on that control plane, which we're not going to do. We're going to do a control plane, we're going to leave it as a control plane, and we're going to stand up a worker, and we're going to join that worker to the cluster, and we'll get into some of the basic configuration to get a Kubernetes cluster running. So I would suggest that you read this, right? And people always ask, well, do I have to read all this stuff? This is how you learn, folks. You go right to the source, right? Kubernetes documentation. In my case, one thing I want to point out too is the latest is 1.29. I'm looking at 1.28 docs. There's a reason for that, because I'm going to deploy a one version, right? One major version lower than 1.29. It'll be a 1.28.8, which I believe is the highest level of 1.28. That way, when we go through some of the operations in the next blog post around upgrading your cluster, backing up etcd, those types of those things, right? We can actually do that and not be on the latest, right? Because if I go to the latest, which is 1.29, what happens is I don't have an upgrade path and I can't show you actually how to go through a manual upgrade. Another thing that you should do manually to see what it takes to do that. I'm not going to get into details on that, but that'll be in the next video. Not this weekend. This weekend will be this video. It'll be the following weekend, which we'll get into more of the operational aspect of the cluster. Right now, we're just standing a cluster up. We're going to deploy a Hello World application. Very, very simple. We're going to make sure it works, and that's where we're going to end. And then we'll get into the operational aspect and some of the components within the Kubernetes cluster itself. So, you need to understand that Kubernetes runs in a container, right? First and foremost, you have to have a container runtime. Now, if you are new to all of this and you're just getting into containers, I would suggest you take a step back, right? Don't get into Kubernetes without fully understanding what containers are, what they do, what are the different container engines out there, okay, or the container runtime interface, as they call it, CRI, that is out there, and why we even have Kubernetes. Remember, containers came before Kubernetes. Kubernetes is a container orchestration, right, and operational platform for containers, right, for applications running in containers. So chicken before the egg, right? If you decide to go with Kubernetes first without learning containers, it's going to be much more difficult for you to understand how this all works. So if you do understand what a container is and what it's there for, right, and what it does, and if you go back to my previous blog articles, you'll get some of that information to have an understanding, a basic understanding. I would suggest that you go out to the internet. YouTube has a ton of content. There's Code Cloud, there's YouTube, there's Udemy. There's a lot of different ways of learning. There's Tech World, I think, by Nana. She's great, right? There's just a lot of content out there, and even free content on YouTube where you can get the basics and even more advanced topics without even spending any money. What you're spending is time, right, to learn this. So what's going to happen is we're going to prep the node for Kubernetes. I'm going to talk about that. We're going to install a container runtime. In our case, we're going to be installing Containerd. And we're going to be deploying Kubernetes with kubeadm. All right? kubeadm is the tool that we're going to deploy Kubernetes with. So we'll have to install that. We'll have to install kubelet and we'll have to install kubectl. I'll talk about what those things are here in a few minutes. But you have to prep the node first. And what is the node? Well, the node in our case is just a virtual machine, right? And on that virtual machine, right, for the control plane, and you'll have a virtual machine for the worker node. That's what we're talking about here. Assume in this case, a node in the Kubernetes world is a VM. Now, it doesn't necessarily have to be a VM. You can run Kubernetes directly on an OS, right? Directly on bare metal if you'd like. But it's much simpler. There are valid points for and against bare metal, especially at scale. When you start looking at scaling, you start looking at more automation, and you start looking at some of the benefits that we already get with virtualization, it makes a lot of sense to go down that path. And by the way, most, if not all, public cloud manage Kubernetes solutions, or those solutions, right? Like AKS, EKS, GKE is an example, all run on the back end on virtual machines, right? And AWS running on EC2 instances, and AKS running on Azure virtual machines, and GCP they're running on Google virtual machines, right? So that doesn't mean you can't do Kubernetes and bare metal in the cloud, but if you decide to leverage a service through those providers, you'll be running on virtual machines more than likely, okay? There is some benefits. Now, there's also benefits from a Nutanix perspective because we're providing you a platform, not just the hypervisor, but all the storage services underneath. So there is container storage, interface driver, right, for Nutanix storage, right, for our block storage, for our file storage. There's cozy drivers for objects. I'm not going to get into detail on that. We'll get into detail later on persistent storage and requirements around that. We do see that growing in the enterprise where, generally speaking, on average, we're seeing probably more than 50% of applications deployed in the enterprise on Kubernetes require persistence and require state. So that requires persistent storage. And with that comes all of the requirements around data protection, replication, automated deployment through programmatic means, through operator framework, etc. And we'll talk more about what that means later, but I don't want to muddy the waters. So let's go into what we're going to do. So you can go through this, right? And you can manually, right, before you begin, create a host, right, with these minimal resources, etc. And it'll walk you through how to install all of these things, okay, manually, step by step. Now, I see tutorials online where a lot of folks do this, okay? What I'm going to show you, and I'm going to provide in a link later, right, when I upload this to GitHub, my GitHub repository, is a cloud-init file, okay, that's going to completely set up the node, all right, and going to do all of these pieces for you automatically. So all you have to do at the end is run a kubeadm init to start the cluster. That's it, right? So that's the beauty of this cloud init file. And I'm going to drag this over so you can actually see it. It's actually a pretty large file here. Now, again, this key will be, this is a key. I shouldn't show you this, obviously, but this is for demo purposes, and this key will be changed, obviously, when I go through my updates on this. Assume this is what you're concerned about is how do I get, right, set the host name, how do I add users, right, how do I add sudo access with no password, how do I enable SSH with a key, right, how do I change my host name, update my IPs, right, for DNS and Etsy hosts, and then how do I update the operating system, install SSH, enable SSH, disable the firewall. And it's not a best use case for production, by the way. Again, this is just lab. I wouldn't disable the firewall. I would open the specific ports required versus disabling the firewall. How do I install, tooling that I like to use? Like I use ifconfig a lot, another network tool, so I install NetTools automatically. I change the time zone to my time zone. I turn the swap off. There's a reason for that. It has to do with kubelet, and it's in the Kubernetes IO documentation. So in these commands here, I turn the swap file, disable the swap, to prevent issues with kubelet. And then I set my filters, my overlay filters, etc., my network bridges. I then get prepped to install container D, right, which is the container interface, the container engine on the back end that's going to be running the control plane, right, and the worker nodes. And I also add the repositories for that, right? Install container D here, restart container D, enable it, right? And what I'm doing here is making sure that container D is running as a service. And then I'm going to, again, do an update after I add the repositories for the three tools I need, which is kubeadm, kubelet, and kubectl. kubeadm, again, is the tool that's going to deploy the cluster, etc. kubectl is how you interact with the Kubernetes cluster and the API server. We'll talk more about that later. And kubelet is basically what allows the interface between containerization, what we call pods in the Kubernetes world, and back to the control plane, right, as an example. And then we're going to mark those, and we're going to enable kubelet. And what will happen is you'll notice kubelet will continue to crash, right, as a service until we initiate the kubeadm init command to build the cluster. Then I do a complete package update and I reboot the server. So again, this is the cloud init file that I'm going to be leveraging when I build my worker, my control plane VM node, and my worker node VM. Okay. Now in the worker node, I'm going to change obviously the FQDN to K8's worker, and I'm obviously going to change the IP address because it'll be a secondary VM before I build that. So let's go ahead and go into Nutanix, and we're going to build that VM under VM. So under VMs, you already see I have a K8's control. I'm actually going to delete this. Actually did some testing to make sure everything was working right. And you'll see that deleted. And now we're going to create a VM. And I'm going to call it K8's control for the control plane. One VM, I'm going to use 2 vCPUs and 4 gigs of RAM. For minimally, you need 2 and 2. I'll just leave it 2 and 4. Again, this is just a lab. We're going to be spinning things up, tearing things down constantly. I'm going to attach a disk. So in the attached disk, I'm going to clone from image. Remember, we uploaded that jammy image, and there it is. So I'm cloning, and I'm going to resize it to 10 gig. Now, you probably don't need 10 gig. I'm just using that as a base, right? So we'll hit save. I'm going to change this to legacy BIOS mode. I'm going to hit net. Oh, sorry. Let me hit back. First, I'm going to attach the subnet. This has to go back to, okay, I've added my tagged VLANs. I have a server IPAM. It's in VLAN 50. I am not going to use DHCP. I'm going to use static. So in my case, I'm going to use 192.168.50.190. That is an IP that's in the pool that I'm taking away for a static IP, right, for this worker node. Now, you're probably asking, why don't I use DHCP? Because if I use a DHCP, then I'll have to go back in to the node and actually update the host file because I won't know what IP address, right, after the cloud-init runs, after boot. So I'm going to use a static IP, and the static IP is set in the cloud-init file already, so it already knows to add this IP address and the host name, right, to the etc host file. So I'm going to hit save, and now I'm going to hit next, and I'm going to go into guest customization. I'm going to use cloud-init, and I'm going to go and I'm going to copy, right? Now, you can point to a file, but I'm going to copy this, okay? And I'm going to paste it in here and hit next. Then I'm going to make sure everything looks right, and I'm going to create VM. Okay, now that's K8's control. I'm going to boot this up, and what's going to happen is it's going to go through the cloud-init file, and it's going to boot up. So you can go in here and you can go to the console if you'd like, and you can watch it boot up. And it'll sit there for a couple minutes because it's doing all those things in cloud-init, and then it'll do a reboot after the upgrade of the, remember the last step is upgrading the packages, right, for Ubuntu, and then reboot if necessary. It will go through a reboot. While we're waiting for that, we're going to go back. We're going to go into the cloud-init file, okay? We're going to change a couple things. We're going to change the host name to K8's worker, and we're going to change the IP to 195. Okay, and we're going to change again the host name to worker. Okay, and now we're going to go down here, copy it, so we have it. We're going to go back in, we're going to create a VM, and we're going to call this K8's worker. We're going to make it 2 vCPUs, 4 gigs of memory. We're going to attach a disk, the same thing, clone from image. Jammy image, we're going to change this to 10 gigabytes. It's not really gigabytes, it's gigabyte, however you say that, right, the GIB. And we'll hit attach subnet. Again, we're going to be using server IPAM static, and this is going to be 195. We're going to hit save, legacy BIOS mode, hit next, cloud-init, customization, paste the script, hit next, hit create VM. Okay, so now that's the second VM that's going to be created. Again, remember you have the control plane and you have the worker node. Okay, we're going to focus on the control plane first, and then we'll get into the worker node. I'm going to boot the worker node up though, because I want it to go through all the installation of all those things so it's ready to join very, very simply. Now this is the power of cloud-init. Now, you're probably thinking, Mike, you don't have to do this. You could do a whole different, there's so many different ways of doing this, right? You can prep an image, right, through Packer. You could use Terraform. You could use Ansible. We're going to do those things in the more advanced sections of getting started with Kubernetes, because we're going to show the power of how quickly you can do this with Terraform as an example, and Ansible, and having a fully working cluster like within 2 minutes, 3 minutes. Okay, ready for production, by the way. All right, so let's go back to, let's make sure the K8s worker is booted and it's going through the boot process. Okay, let's go back to the control plane, console. Now, I don't know if this booted yet. I'm going to wait a couple minutes. I'm going to pause. I'm going to wait a couple minutes and we'll pick it back up. Okay, so I waited a couple of minutes, waited for the cloud-init to run and go through all the implementation and the last reboot. So we should be good to go. What I'm going to do is I'm going to make sure all the tools are there. So the first thing we're going to do is to make sure containerd container engine is running. So let's do a sudo systemctl status containerd. Okay, and you can see that's running, so we'll hit Control-C on that. Let's copy that. We'll do the same thing on the worker node, and you can see it's running there, so we'll hit clear on this. We'll hit clear on this. Let's go to the kubeadm version command to make sure that we have the right version. Kubeadm version, and you can see here we have version 1.28.8. That is the latest 1.28 release. Again, 1.29 is already out. If I change the repository, right, to the 1.29 repository, it would install 1.29. So we're not going to do that. Remember, we're doing 1.28. Now, if you read the directions on Kubernetes.io, all of these things, right, have to be the same version. So kubelet, kubeadm, and kubectl all have to be the exact same version. Okay, they can't be different versions. Now, theoretically, you could have a kubectl, I believe, that's newer and it will still work, but best practice is to make sure that all three are the same version, which they are. So we're going to go back in and just double check all of them, which we haven't done yet. We only have checked kubeadm. So we're going to check kubectl version 1.28.8, kubectl version 1.28. Kubelet version is going to be with dashes. 1.28 version. Okay. Now, another thing we're going to check real quick is to see that the kubelet service is there. It won't be running. More than likely it'll be in a crashing state, which is normal until you run the init. So let's do this. Sudo systemctl status kubelet. Right, and it's activating, it's not running, right? Same thing here, we'll do the same thing. Systemctl status kubelet. And you can see here the main failed with result, etc. Let's see if this does it again. Yeah, so the same thing. So this is exactly the state that it's going to be in until you initialize the cluster, and for the worker node until you add the worker node to the cluster. So all the work is going to be done to start on the control plane. So let's start with the control plane. So we're going to clear this. Oops, if I can spell. Clear. And under K8's control, we're going to do a kubeadm init command. And what that's going to do is it's going to initialize a cluster. Ooh, I may have done something wrong. Let's see. kubeadm. Oh, I didn't do sudo. Hang on 1 second here. Sudo kubeadm init. And you can see here it's going through what's called pre-flight checks, and it's pulling the images required for setting up the Kubernetes cluster. Because the Kubernetes itself, from a control plane perspective and from a worker perspective, will have pods running in that, right? Or, containers that'll be running to actually deliver the overall experience of Kubernetes, right? So before you even run an application on a node, right, there'll be Kubernetes pods for different services, and we'll talk about some of those here in a little bit when we connect to do that. So let's wait for this to get done, and we'll be back in a minute. Okay, so they can see that it's done, and you can see that it says your Kubernetes control plane has initialized successfully up top. To start using your cluster, you need to run the following as a user, right? So you have to make a directory, home./.cube, and you have to copy the config file, right, to this directory. Now, what is this for? So what happens when you run kubectl to interface with the cluster, the API server, it needs to have a key, okay, and a certificate validation. So what happens is, what we're doing is we're copying the config that holds all of that configuration. And by default, when you run kubectl, it'll reach to this default directory, this .cube/config directory, okay, and access that file for the authentication to the API server, okay. Then there's also, you should now deploy a pod network on the cluster, right? So I think this is a little, this is in order. So the first thing you need to do is you need to be able to access the cluster using kubectl, because in order to install what's called a CNI, a container network interface driver, right, you need to have kubectl working. And so what you'll do is you'll do this first, right? Or if you're a root user, you would actually do this, right? I am not a root user. I don't use root, right? I think it's a bad habit. I see people do this all the time. Do not use root. If you need to have root access, then you need to su or use sudo, right, to privileges to do that. But what I would say is do this next. So you have the kubectl config file. Another thing you can do is you can SCP this config file to a to your Windows machine, right, where the config file is. Maybe you're running WSL. In my case, I use Windows 11, but I have WSL and I have Ubuntu running under WSL. I copy the config file there. That way, locally within my VS Code, right, terminal, which I connect to my Ubuntu desktop, right, or excuse me, my Ubuntu WSL machine, I can actually access the cluster remotely using kubectl as well. For now, we're going to stay on the control plane since we're puttied into this, okay, and we're SSH'd into this using putty. And then after you have the container network interface driver installed, okay, then you can join any number of worker nodes by running the following on each as root. So you can sudo this command, kubeadm, and join, right, with this token. Extremely important. And you can go back and get this token. I don't remember the command offhand, but you'll need this, right, to move forward in joining this worker to this cluster. So in order, we're going to get the kubectl, the config file, right, set up. I'm going to attach the cluster. We're going to see what it looks like a little bit. It won't really be a cluster right now. It'll just be a single control plane. We'll then install a container network interface driver, right? In my case, I think we'll choose Calico. And there are many out there: Flannel, WeaveNet, Calico, etc. There's a ton of different ones you can use. I'm going to leverage Calico. It's one I'm the most familiar with, and I like the most right now, because it's a combination of Cilium and Flannel, right? Which is two of my favorite things. Now, Cilium is another one. Cilium is more advanced. But I would say that's probably my favorite from an advanced perspective, but I'll choose Calico just for this demo. So again, and then we'll join this worker to the cluster and be able to see both. So the first thing we're going to do is we're going to copy this and we're going to run this. Okay. And now if you go to cd right, you'll see the config. And what happens is it copies the information in this config file. And by default, kubectl uses config. So what we're going to do is do kubectl get nodes. And you can see here I have the K8's control plane. The status is not ready. The role is control plane. How long has it been up? And what version is it running? Now, this is the basic command. kubectl get nodes, right, is a very basic command. It's the first command you could use. You could also get some more detail. I'll talk to you more about that in another session as we go through some of the different commands in kubectl in the next series. This is a very basic thing, but what we're focused on is the fact that this cluster is not ready. And it will not be ready until you install a container network interface driver, which we're going to do right now. Okay, so I went to the docs.tigera.io, and Tigera is basically I wouldn't say company, but the organization that has created Calico, right? And we're using the open source version. So what we're going to do is we're going to download the Kubernetes manifest file. Okay, so we're going to copy this, and we're going to go back into our node. Let me go back to the home directory. Okay, and now we're going to get this file. So now if we ls on this, we have the calico.yaml file. So within this, you can look at this. Let's go to calico.yaml. And you can see here exactly what it does. Now, we're going to get into YAML specification for Kubernetes a little bit later. But what we're doing here is we're creating what's called a manifest, right? And this is the declarative way of working in Kubernetes. So I create a manifest file, and I apply that manifest file against the API server, which basically tells Kubernetes to do whatever it is I want done via the YAML file. In this case, I'm creating a policy, which is a pod disruption budget, right, for the kube controllers. Make sure that my availability is no less than 1 for the controller. I'm going to create a service account, right? We're going to call it Calico Kube Controllers under the kube system namespace. We haven't even gotten into namespaces yet. We'll talk more about that later. But again, this is basically the configuration file, right, that you're going to use to deploy things. And it's not just for CNI, it's for everything you do within Kubernetes. Now, if you're more advanced, right, you're probably not watching this, but if you're critiquing me, you're probably saying, well, we don't do that either. There's other ways like GitOps we can do things. And you're right. That's further down the path, and we're going to talk about that in another section, in the more advanced sections later as well, where you'd want to deploy things declaratively through a GitOps practice, which is basically I upload my configuration manifest, like this as an example, into my Git repository, and I have a tool like an Argo CD, right, monitor that repository for any changes and automatically deploy and apply that YAML file to my Kubernetes cluster. That's further down the road. Okay, I'm not here to talk, this is a very basic 101. If you're expecting more advanced stuff, you can hold on for that. We are going to have more advanced stuff, but this is 101 up front. So again, I'm just going to get out of this. We have this file. I'm going to do what's called an apply. So let me clear this. Oh, probably shouldn't have cleared that. Hang on 1 second here. And I'm going to now apply the YAML file. So I'm going to copy this. I'm going to go back in to the control plane, and I'm going to now apply the YAML. So I'm declaratively applying the configuration that's outlined in that Kubernetes manifest. It's creating service accounts, secrets, pod disruption budgets, config maps. It's creating a cluster role, and it's binding that account to that role through the cluster binding. It's creating a daemon set, something we'll talk about later, and a deployment, which is basically a declarative way of deploying an application as an example. Okay, so now when I go back into kubectl, right, get nodes, I see that my control plane is ready. And what I'm going to do now is I'm going to go back to my worker node, and I'm now going to join my worker node to the cluster. Okay, so I didn't copy the join command with the token for this. So what I'm going to do is I'm going to create through the kubeadm token create print join command. And now this is giving me a new token, right, to look for. So what I'm going to do is I'm going to copy this. And I'm going to go over to the worker node. I'm going to paste it. Oh, sorry, I have to be sudo again. Sudo. It's these little things that sometimes you forget. And then it's going through again the pre-flight checks, right? It's starting the kubelet, right? Waiting for kubelet to perform the TLS bootstrap. It's validating the certificate and letting know that you can see here on the control plane to see this join the cluster. So now if we go back in here, I'll hit clear and I hit kubectl get nodes. You now see that I have a K8 worker node here. And so what I just did here is I noticed that when I hit kubectl get nodes, it showed not ready. You can see here it's not ready. And then what I did was a kubectl get nodes. And if you do a -- watch, you can actually see things in real time change, right? So it takes a little bit for the K8s to actually get the CNI, right? Get all the pods required under kubesystem for Kubernetes to work, etc. And we're going to look at that here in a few minutes here. Okay, so I waited a little bit and I see all of the services are up and running now. You can see here my Calico CNI kube controller is running. I have node pods for both nodes, the control plane as well as the worker. Core DNS, same thing. etcd, which is your key value pair database. I talked about that a little bit. That holds your cluster configuration information. This will need to be backed up. We'll cover that in the maintenance section. Kube API server is exactly what it is. It's the API access into your cluster. Kube controller manager, proxy, and scheduler. And of course, I think we talked about scheduler when it comes to scheduling pods on the cluster. So if we do now kubectl, let's clear this here. Kubectl get nodes. You can see here that I have a control plane node and a worker node. Okay, and the roles here are set. You have the role control plane, and so what this is this node here, K8's control plane, is tainted, which means that you cannot run pods, application pods, on the control plane. So I can't schedule application pods on the control plane. This will only be able to run pods that are associated with the duty of a control plane. Now you can remove the taint off of this control plane node and be able to schedule normal application pods, and you could have a one node cluster, so to speak. And I could have started there, but I don't want to do that. I actually wanted to show you actually how to do an upgrade with a worker and a control plane node. And we'll do that in the next section. So again, kubectl. I talked about this. This is going to be your solution to interface with the cluster. Another thing you can do is you can create an alias if you'd like. So if you don't want to type out kubectl all the time, you can create an alias. I think it's alias k equals kubectl. So now if I go k get nodes, you can see here I can just use the abbreviation K. So I'm creating aliases for the kubectl. This, I'll give you a hint. Using aliases for some of the common things actually helps speed up things, especially on the Certified Kubernetes Administrator exam, because you are timed in that exam and you have so much time to complete tasks. So having some aliases, you don't need to go crazy. I have seen some YouTube videos and some blog posts where folks will give you an alias for, make an alias for everything up front before you start the CKA, and you don't really need to do that. You can do a few because there are common commands. kubectl is certainly the biggest command that you'll use, the most common one. So you can see here I'm using K for kubectl now with the alias. I'm getting nodes. Nodes is the actual virtual machines, the control VM, and the worker VM, right? And if I do k get pods and I go A means all namespaces. So what Kubernetes does is you're able to kind of segment, not physically segment, but logically segment your applications or your pods, so to speak. We'll talk more about pods and what they are, but basically it's an application, right? And people always say, well, pod is a container, and that's not true. Containers run in pods, Generally speaking, it's a one-to-one relationship, so a pod per container in general is one-to-one, but you may have other containers like init containers or sidecar containers within a pod next to your application container that do specific tasks. Maybe there's a logging mechanism. Maybe there's an init container, meaning something has to happen before the actual application container spins up within a pod. But generally speaking, you will have, generally, again, and I know some people may argue with this, but generally speaking, you'll have a one-to-one relationship with pod and container. So again, get pods all, and you can see here it's listing out all the pods in all the namespaces. And the only namespace that's available in this platform today is kube-system. There is a default namespace that's not listed here. If I deploy an application, which I'm going to show you here in a minute, it will automatically go to the default namespace, right? So if I say get pods without the -a, all namespaces, that automatically looks at the default namespace. You can also create namespace, which is basically kubectl create namespace test as an example. And you can see here that namespace test is created, and now I can schedule in pods within that namespace. And so you'll hear people talk about things being namespaced, right, within Kubernetes, and really it's a logical segmentation within the node to run your applications. In the instance of all the pieces that are required to run Kubernetes, most of them will be in the kube system namespace, which is an automatic namespace created during cluster creation. And so if I go here and go list namespaces, get namespaces, you'll see here I have the default namespace. There's a kube node lease, a kube public, kube system, and the test namespace that we just created. So let's do this. We're going to deploy a simple hello world application. So kubectl run hello image equals hello world in the namespace test. So you can see here pod hello is created, and now if I go and say get pod hello in namespace test, you'll see here that it's in what's called a crash loop backoff. I may have not specified the image correctly. So let's go here. We can watch it. So another command that's very useful is the watch command, because this actually gives you live monitoring of what is happening, right? So I can say watch get pod hello in the namespace test. Watch kubectl get pod hello namespace test. Okay, so you can see here that it's continuing to go into a crash loop backoff. So one of the things we can do is klogs. You don't have to use the pod command because logs is only for the pod. So I can do klogs hello namespace test to see if I can get any. Generate this message. This message from the installation appears to be working correctly. Docker daemon stream to output. Try something. Okay. So one of the things I can do also is describe pod hello namespace test. Okay, and this will give me more information. The describe command you'll use a lot because it'll basically tell you exactly what's going on down here in the events, right? So you can see here it successfully assigned test hello. Well, let's look at before we do that, let's look and see where the status. So hello world, state is terminated, reason completed, last state terminated, completed. I believe what happens in this, right, in this hello world application is it deploys, right, and then it terminates automatically. So let me just see here. Here's the container ID. Here's the Docker imagery it's pulling hello world from, right? And you can see it's terminated. And you can actually go through the events to see exactly what happened. Pull the image, right? Including, right, it's waiting. Create the container hello, start a container hello, successfully pulled the image hello world in the amount of milliseconds, right? And it back off restarting failed container hello and pod hello test. Pulling image hello world. Let's see if I can do that again. If anything changes. Okay, nothing changed. Okay, so just a brief example. Let's see if there's, let's see if I can do, let's clear this. And we're going to do krun bb. That's the name of the pod. Image equals busybox and namespace test. Pod bb created, so we can watch kubectl get pod bb namespace test. Okay, it's also doing that. K describe pod bb namespace test. And you can see there I actually abbreviated pod too. So there's some abbreviations you can do. I didn't type out pod, I said PO. And again here, let's see. Back off restarting failed container in bb in pod. Pulling image busybox. Okay. So there's definitely some things going on here. I'm not going to get into the, the troubleshooting section as of yet. We'll get there. But, this is your basics of how to stand up a cluster manually. I wouldn't say it's simple. I would say it's detailed. You need to pay attention to the details. And also, when you go to kubernetes.io, all right, let me see where that is. And you go to the site, you need to make sure you pick the version that you're going to install because sometimes things change. Okay, and when things change, right, you can see here, this is for 2.8, 1.28. This is the reason I'm using this. The latest version is 1.29. I think 1.30 is actually right around the corner, but 1.29, right, if you decide to go down this path, you will click this link and go through the installation guide for 1.29. You also do not need to use kubeadm to create a Kubernetes cluster. I was just showing you this because to me it's the most manual process. It kind of gives you an idea of what it takes to actually stand up a cluster and get it ready for some basic workloads. As you can see, my cluster is not fully ready yet. This is nowhere near a production solution. I talked about this in my blog post around Kubernetes. There's a mind map in the beginning blog post I laid out of how, all the things you need to think about of getting your Kubernetes solution production ready. And we'll walk into that, right, through a stepped process. So I hope you enjoyed this video of starting out. In the next episode, we'll talk a little bit more about, not so much about deploying applications, but maintenance operations, okay? We're going to go through backups of etcd. We'll talk about how to restore etcd. And we'll also go through an upgrade of the cluster, especially when you have applications running. And this is very important because it goes through a stepped process, all right? And you need to see what that takes to go through it manually. Again, all of this is for your benefit to understand the pieces, parts, components, what it takes to stand up a cluster manually, how to operate it manually, etc. So you can, when you look at your third-party solutions, such as like an NKE or a Day2IQ solution from Nutanix or an OpenShift or a Rancher, you'll understand the benefits of what those Kubernetes platforms and operations, right, really provide you. Being able to deploy a Kubernetes cluster, within 5 minutes without going through any of this, right, is extremely, extremely valuable. Being able to upgrade it automatically without going through a manual process, which we'll show you next week. But for now, I hope you enjoy this video, and I'll see you in the next one.